viewers, welcome to another session of your course Internet of Things, Design Concepts and Use Cases. In the previous video, you have learned how to control your LED with the help of a switch, which was a direct on and off control. So, in that practical we have learned that if we press the switch, how the LED behaves according to the movement. Now, it will be interesting to add a potentiometer into the circuit, where with the help of the resistance control on the potentiometer, we can change the intensity level of your LED. So, in order to do that, we have a interesting application of LED bar graph. Although in the market you will have a direct chip for LED bar graph design, but today we are learning it right from the scratch, and in order to do that, I will be interfacing different LEDs to your potentiometers. But before we learn that, we have to learn interfacing one LED with potentiometer, so that the same thing we can apply on multiple LEDs later. So, you can see on your screen now, we have a simple connectivity for interfacing LED potentiometer with Arduino board. You can see here, we can connect your LED on any of your digital terminal. With the help of a resistance, we can further control current to this tiny circuit. And along with this, we can connect a potentiometer into your circuit depending upon what intensity changes you want to see in your LED. You can have different values of potentiometers. In today's experiment, I will be using a 10K potentiometer, whose intensity we will be dividing into 4 different parts to see changes in LED intensity levels. The circuit will be pretty simple. First of all, we have a potentiometer. You can see we have connected it on one of the analog terminals. So, depending upon how you need to define it on the hardware side as well as on the software side, you can choose any one of the pin from your analog port. And similarly, the LED I have connected on one of the digital pins over here. The same connection we have to design on the hardware side now. So, let us see, we have one Arduino board, we have LED, one resistor, and we may need wires for first LED connection, and then we have your potentiometer with this notch that we can control just by rotating it. You can find so many versions of potentiometers in market. Many are designed with a chip based module as well, and this one is the most raw one you will find with direct pins available for the connectivity. Now, on your potentiometer, those who are new to potentiometer, let me first show you a slide describing your potentiometer terminals. On your potentiometer, we generally have 3 terminals. One is your terminal 1 that you can define either as VCC or ground. Similarly, the other side of the terminal you can consider the vice versa. So, it basically defines this portion and this portion of your potentiometer, and then in the middle we have one variable pot that we can use to adjust resistance level of this potentiometer. So, while dragging it from one position to other position and taking it back, it will help you to get different values of resistance for your circuit ranging from 0 to maximum value of your potentiometer. So, the same arrangement we have on the hardware side. With the help of a wiper, we will be changing resistance of the hardware. So, let us see the same thing on the hardware side. We first have to connect your LED. So, I have inserted one LED here in the breadboard, and in order to control resistance through this particular circuit, I have added a 220 ohms resistor in sequence. Now, one terminal of this LED I will be using for the ground, that definitely will be your cathode terminal. So, always check flag of your LED for this connection. So, here I am inserting this particular into ground terminal of my Arduino board. Similarly, we have the other anode terminal of LED in sequence with the resistance, and that we can use over any of the digital pins in this port. So, let me choose one random pin. For example, we have pin number 10 over here. So, I have connected it. Next, we have in hand your potentiometer with these 3 wires. The middle one will be your wiper. One of these terminals, the outer ones, you can use as VCC or ground as per your choice. So, let me consider this first terminal as a ground terminal, and this one I can connect here on your Arduino ground. So, here we have that on the power board, and similarly the other end of this potentiometer I can connect here on the 5 volt. After this, we are left with the wiper that I will be connecting on the analog port of my Arduino. So, here I have selected pin number A2 for example. So, this will be your hardware connection now. We can switch to the software part to understand the code that we will utilize to run this particular circuit. So, let me take you to your favorite software platform, that is your Arduino IDE. So, here is a very simple code. First of all, we have to declare your LED pin number. So, this is pin number 10 on the software side, and we have selected the same pin on the hardware side. So, this should be fine. Similarly, the potentiometer pin we have declared, that is pin number A2, and same pin I have used on the hardware side. Next to this, we have the void setup. Here I have selected LED pin as output and similarly potentiometer pin as input. And then we are switching to the loop part, where first I am reading the analog value from the analog port where I have connected the potentiometer, that will be your pin number A2. And you can see I have used function analog read over here. And next to this, the brightness level I have to adjust for your LED, and for that I have just divided the potentiometer value by 4, so that your total intensity range for this particular potentiometer will be automatically divided into 4 levels to adjust LED intensity levels, and ultimately the same brightness level I am setting up for your LED pin. So, this is a very simple sequence of code we have designed now, and now it is time to shift this code to your hardware board. So, first of all, as we know, we have to connect your USB terminal, and we will be inserting it into USB port of your system. After that, we have to compile and upload your code, but of course, before that we need to select the port, as well as we have to verify if board is selected accurately. So, this task we are done with, and now we can click on the upload button. It will first compile your sketch, and after that it will upload the code into your Arduino board. So, currently the code is ready on your board, and let us see how it varies with your potentiometer. So, let me just adjust its range from minimum level. So, you can see the LED is off now, and slightly it will vary as I increase intensity. You can see slight increase in intensity level, and further it keeps on glowing higher, and you can see at the final terminal we have the maximum glow in your LED. So, in the similar manner you can add some lamps or many other things that you want to control based on your lighting arrangement. But now, this is just with a single LED. We are going to design a LED bar graph. First of all, what will be your arrangement for a LED bar graph? Let me show you a slide for that. And we will just see the simple circuit extension for your LED bar graph. Here you can see earlier we have utilized only one LED, probably this one we can say, but now I have added 7 more LEDs, or maybe you can add more depending upon how big design you wish to create. So, the simple sequence now we have is, first of all we have LED connected through your resistance with the digital pins on your Arduino board, and the same sequence of LEDs ranging from LED number 1 to 8, all of them we have connected in sequence with your digital port right here. And on the other side we have a potentiometer that in the similar manner, same as single LED interface, we have to connect it again on the analog port of your LED. So, the same thing I will be designing now on the hardware side. And first of all, let me take out this connection and let us extend it further to a detailed one. So, I have one module ready for you here, and let me first explain you different connections that we have done over here. Here you can see a sequence of LEDs, and based on this sequence of LEDs, because this is the cathode terminal of LEDs, I have used a ground common over here, and this particular ground terminal I have taken to the ground terminal of my Arduino board. At the same time, the analog, all your anode terminals from the LED side, I have taken in sequence to here your digital pins. So, it will be distributed from pin number 2 to pin number 9 over here. Depending upon how many LEDs you want to add further, that is your choice. And in the middle part, you can see a sequence of resistor that I have added to control current for each respective LED here in sequence. Now, this is your LED sequence. One thing we need to add into the circuit is your potentiometer. So, earlier we have utilized this one with a single sense LED, but now with your multiple LEDs, and in the similar manner we may need to make changes to your code. So, first of all, let me make connections for your pot. So, for this, first of all we have the ground terminal. So, let me choose one of the terminals from the extreme end as ground. Other extreme end terminal I can choose as your VCC terminal, and similarly one analog terminal on your wiper. So, these are your 3 important connections on hardware side. Based on this, now we need to check your code. So, let me take you again to the IDE platform where we will just visualize code for LED bar graph. Here in sequence you can see we have added number of LEDs first of all into the sequence. That will be LED count 8 over here. Earlier there was only one LED, so we need not to define LED count, and we have splitted all your resistance readings into single LED. But now I have declared a LED count of 8 over here, and next to this analog pin for your potentiometer has been declared, and next to this we have declaration for all the digital port pins on which I have connected the LED sequence. So, it ranges from 2 to 9 over here. Next to this we have the setup part, in which I have created a small for loop, because at this position I have 8 different LEDs, and I need to control them one by one with a output mode. So, for this I have created a simple sequence with for loop. First of all, this LED 0 has been declared, and then I have to check if this LED is less than LED count, which is already declared as 8, and based on this condition only we are further checking the next LED number. So, that is your this LED plus plus, a simple C programming we are doing here. And considering this for loop condition, we have added a body to your for loop that will simply declare pin mode of respective LED as output one by one. After the setup part, we have the loop section, in which first of all I need to check the analog pin, and I will be getting sensor reading from the respective analog pin where we have added the wiper pot. And after this I have used a map function over here. Earlier we have divided potentiometer readings directly by 4, but now I am mapping them from LED sequence, and here you can see, because we have a 10K pot and the analog sequence for that is ranging from 0 to 1023, that makes up total count of 1024 readings. So, this sequence will be now divided or mapped to 0 to your LED count, which is 8 in this case. And based on this LED level mapping that we have done, the next for loop sequence we have created to make these LEDs high and low one by one, depending upon how we are increasing the intensity level of your variable resistor or potentiometer. So, this is a simple sequence of code that we have added on your IDE platform. So, I can compile this, and in the meanwhile I can add the USB port connection. So, as you know, we simply need to insert this into the USB terminal over here, and it will soon make your Arduino ready. You can see the LEDs glowing over here, and next to this we have to upload your code after checking port and board. So, I can now hit on this upload button. As soon as I click on the upload button, the code will be compiled and then it will be uploaded to your Arduino board. And based on this now, we can see our output sequence. So, let us vary your potentiometer pot over here, and this one I am just taking from one level to next. So, a slight change I have made on the pot over here, and you can see the first LED turned on. I can increase it further, and second LED also turned on, and we can similarly keep on increasing it, and depending upon how many LEDs we have, you can see all LEDs turned on as the pot is at its final position. Similarly, if I take it back now, you can see one by one all LEDs are turning off. So, this is a very interesting sequence of LED bar graph, and depending upon how you control it with which speed, you can see the LEDs turning off fast and turning on fast. So, this concept basically creates a baseline for designing your Diwali lights. So, students, you are now ready to create your own design for this time festival, and you can create a long sequence of LEDs for your home as well with your basic project. So, thank you very much for this particular video, and we will meet again with several new sensors to learn more about IoT basics. Thank you very much.